Suppose the total number of students in class 10 of your school is 100. 60 students out of these 100 like mathematics, and 50 students like history. 30 students like both maths and history. Let us talk in the language of probability. What is the probability that a selected random student likes math? A student selected at random likes mathematics is an event. The probability of that event will be 60 upon 100. Similarly, a student selected at random likes history is also an event, the probability of which will be 50 upon 100. Can we find the probability of the event that a student selected at random likes at least one of the two subjects, mathematics or history? We can. Let's see how. We can find the probability of happening of an event by using the definition of probability. We know that the probability of an event A is equal to the number of sample points in the event A divided by the number of sample points in the sample space S. But this definition cannot be used to find the probability of at least one of the events A or B happening. A theorem known as Addition Theorem helps us solve these types of problems.
The addition theorem of probability states that if A and B are any two events, then the probability of happening of at least one of the events defined as the probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B.
It is fairly simple to understand the proof of this theorem.
We know that events are nothing but sets. From our knowledge of sets, we know that the number of elements in the set A union B is given by the number of elements in the set A plus the number of elements in the set B minus the number of elements in the set A intersection B. Now, divide this equation by the number of elements in the sample space S. This expression, by definition of probability, gives us the addition theorem of probability. We can also rewrite it differently as shown.
Let us go back to our problem and try to find the probability that a student selected at random likes at least one of the two subjects, mathematics or history. Let A be the event that the selected student likes mathematics and B be the event that the selected student likes history. Then, probability of A is equal to 60 upon 100 and probability of B is equal to 50 upon 100. Now, since 30 students like both maths and history, the probability of A and B, in other words, probability of A intersection B is equal to 30 upon 100. Now, let us apply the addition theorem of probability to find the probability that a student likes maths or history. We get that the probability of A or B, that is, probability of A union B, is equal to 4 upon 5. Let us discuss the addition theorem in the case of some particular types of events. Recall that two or more events are said to be mutually exclusive if the occurrence of one of the events prevents the occurrence of the other. So, A and B are called mutually exclusive events if A and B don't have any element in common. In other words, the number of common elements in the set A intersection B is 0. In such a case, the probability of set A intersection B is 0. Now, we use the addition theorem. We plug in the probability of set A intersection B as 0. Thus, if A and B are mutually exclusive events, the probability of at least one of the events A or B is the sum of their probabilities. Now, recall when mutually exclusive events are also called exhaustive events. Two events are mutually exclusive and exhaustive events if at least one of the two events certainly happens and they do not occur simultaneously. So, if A and B are mutually exclusive and exhaustive events, the probability of set A intersection B is 0, and the probability of their union is unity. Applying the addition theorem of probability in such a case, we find that the probability of at least one of the events A or B is equal to the sum of their probabilities is equal to 1. Let us solve some problems using addition theorem of probability. If E and F are events with the given probabilities and the probability of E and F is also given, find the probability of E or F. Let us apply the addition theorem of probability.
We substitute the given probabilities to find the required answer for the probability of the event E or F.
Let's take another problem. In class 10 of a school, 40% of the students like mathematics and 30% like biology. 10% of the class likes both mathematics and biology. If a student is selected at random from the class, find the probability that he likes one of the two subjects, mathematics or biology. Let A be the event that the selected student likes mathematics and B be the event that the selected student likes biology. Probability of event A is equal to 2 upon 5 and the probability of event B is equal to 3 upon 10. The probability that the selected student likes both mathematics and biology, that is P of A intersection B, is equal to 1 upon 10. Now, we use the addition theorem of probability to find the probability of A or B, that is probability of A union B. Thus, the probability that the selected student likes mathematics or biology is equal to 0.6. If A and B are events with the given probabilities, find the probability of A or B if A and B are mutually exclusive events. We are given the probabilities of the events A and of B. For mutually exclusive events A and B, the probability of A or B, that is A union B, is equal to the probability of A plus probability of B, since the probability of set A intersection B is 0. So, the probability of A or B, given that the events A and B are mutually exclusive events, is equal to 4 upon 5. A bag contains 9 marbles, of which 4 are red, 3 are blue, and 2 are yellow. The marbles are similar in shape and size. A marble is drawn at random from the bag. Calculate the probability that it will be either red or yellow. There are 9 marbles in all, so the total number of possible outcomes is 9. Let the events A and B be defined as shown. The number of red marbles is 4. Hence, probability of the event A is 4 upon 9. The number of yellow marbles is 2. Hence, the probability of the event B is 2 upon 9. The event either red or yellow may be described by the set A or B, that is A union B. Since A and B are mutually exclusive events, the probability of A or B is equal to the sum of the probabilities of A and of B, which is 2 upon 3. In an entrance test that is graded on the basis of 2 examinations, the probability of a randomly chosen student passing the first examination is 0.8 and the probability of his passing the second examination is 0.7. The probability of passing at least one of the 2 exams is 0.95. What is the probability of a student passing both the exams? Let A and B be the events of a student passing first and second examinations respectively. We are given the probabilities of the events A and of B and as well as the probability of either of 2 events happening, that is A or B. We substitute the values in the addition theorem of probability. We can now find the probability of the event A and B representing the probability that a student passes both the examinations. The probability of solving a problem by 2 students, Arun and Anu, are half and 1 by 3 respectively. Is the probability that the problem is solved equal to the sum of the 2 probabilities? Justify your answer. Let A be the event that Arun solves the problem and B be the event that Anu solves the problem. The probability of A is equal to 1 divided by 2 and the probability of B is equal to 1 divided by 3. The problem will be solved if at least one of the 2 students, Arun or Anu, solves it. That is, we need to find the probability of A union B. We will use the addition theorem of probability to find it. It may happen that both the students, Arun and Anu, solve the problem. Therefore, the 2 events here are not mutually exclusive. So, the probability of A intersection B is not 0. Thus, the probability that the problem is solved is not the sum of the 2 probabilities.